Hi, this is Leetcode. Question is graph bipartite. In this example, you can split the graph into two groups, 0, 2 on a group, and 1, 3 in the second group. And as you can see, the nodes in this group are not connected with each other. And all the edges comes from the first group to the second group. So the answer for this one is 2. For this example, it's impossible to split the graph into two groups. In this example here, if we take these nodes as group 1 and these nodes as group 2, you can see every node in this group is not connected to any node in the same group, and the same for this group. So all the edges goes from the group 1 to group 2, and so we will return true for this example. Now we'll use BFS algorithm to solve this question. We need three array, G1, G2, to know if the nodes added to group 1, to know if the node added to group 2, and visited, to know if the node is already visited so that we cannot visit it again. And with the BFS, we will collect the nodes in the first island to find the solution. If it's false, we return false. If it's true, we go to the second island. If it's the solution is false, we return false. If it's true, we are done. We return true. So the visited, we iterate over all the node from 0 up to n, and if the node is already visited, we don't need to do anything. We start with node 0. This flag is G1. Is it true? Is G1 is it true? That means in the next iteration we will assign all the nodes for this level to true. So because we are starting with node 1, node 0, so this will be assigned to group 1 because this is true. Now after we're done with this iteration, we will flip this flag, so all the neighbors of this node, or all the nodes in the next level of the BFS, will be assigned the negative of this, because this will be false, so we will assign this to group 2. And in the third iteration, we will flip the flag and the neighbors will get group 1. In the fourth iteration, we will flip the flag and this will get G2. And then we move to the next island. Again, we start with the group 1, and the neighbors in the second iteration will take the group 2. So we have 0, 1, 2, 3, 4, 5, 6 nodes, and we have group 1, group 2, and visited. Initially all of them are false, and the parameter is true. We start with the first node 0, so we push it to Q, so Q will have node 0, and the number of nodes in this level is 1. So we keep iterating, we take all the nodes in this level, so we have node 0, and we push the neighbors of it to the Q. This is the BFS. Now the current node is not visited, so here we do check. The boolean is G1, so we assign the node to G1, so 0 go to group 1, so with this we set this to true for node 0, and here we iterate over all the neighbors of the node 0. In this case they are 2 and 3, and we push them to the queue, and here we have the count. We increase the count for the next iteration. So for the count we have 2 nodes pushed on the queue. So after this, Q will have 2 and 3, and the count level is 2. This is normal BFS. And here we flip the flag, so the flag is false. Now in the next iteration, what we will do, we'll take 2, for example, from the queue. 2 is not visited, and this is false, so we assign 2 to group 2, So 2 go to group 2, and the neighbors of 2 is 0 because it's visited. We will not push it again to the queue. And also we check because the neighbor which is 0 is visited and the current flag is false, which is this condition. Now we need to verify if this node in group 2 means there is something wrong, but we know node 0 is in group 1, so everything is okay. Now node 3, again node 3 has we assign it to group 2, so we put this to true, and again we iterate over its neighbors. The neighbor 0 is assigned group 1, so it's okay. Now we have node 1, it's not visited, so we push it to the queue, so the queue has node 1. Then we flip the boolean variable. Now it's a true, the boolean is g1 is true again. Now in this iteration we pull the 1 from the queue, and the boolean is true, so we assign 1 to first group, and we check all of its neighbor 3. The neighbor 3 is already visited, and we come to this condition because the current one is true. This one should be in group 2, so if it's in group 1 we return false. Since 3 is in group 1, it's okay. And we have 4, we push 4 to the queue has the value 4, and we flip the boolean again. This is false. Now with 4 we pop it from the queue, and the neighbors of 4 is 1 is assigned the correct variable of a correct group 1, and the boolean is false, so we assign 4 to group 2, so group 2 obtain the node 4, and that's it. We are done with the current island. Then in this loop we move to node 1, but node 1 is already visited. Notice here we marked all these nodes that we are visited to true in the visited array, so all these nodes are already visited. 2, 3, 4 visited. Then 5 we start a new PFS starting with flag true, so this will go to group 1 and this will go to group 2, and that's it. We return true for this graph. Now if we said this is group 1, this is group 2. Now if we connect these two nodes together as in this graph, answer will be false, because let's say this is group 1, this is group 2, and this is group 2 because it's connected to this. Now when we come to this node here, all its neighbor should be in group 1, but this one here, the link is connected to this, which is group 2, so this condition will return false.